All right, attempt number 2. Hello, guys, and welcome to another class with Sanchez. This time we're doing algebra 2. I mean, geometry. Haha, algebra 2. We wish. We wish it was algebra 2. We're doing lesson 1-2, more geometric figures. That means we're going to be going over some more geometric shapes and stuff. All right, so our learning targets today are to describe angles and angle pairs. We're going to go over that in a bit. And then identify and name parts of a circle. All right, so we need to be able to do that. All right. First of all, there's 4 types of angles that we refer to by name. All right. First, we got the acute angles. Why are they acute? Because they're very small. What's so special about acute angles? Their measurement, the angle measurement is between 0 and 90 degrees. So it cannot be 90 and it cannot be 0, but it can be anywhere in between. What do those look like? Well, they usually look like something like this. It can look like this, and they'll call this 60 degrees. It can go like this, and they'll call it 45 degrees. We call it 30 degrees. We go 80 degrees. Basically, it's any angle that's smaller than 90. Remember, 90 is when it's like this. So this is not one of those examples. But we're just going over anything, anything that's small, it's like a small angle. It could even be like this small. And that could be like 1.1 degrees. It's still an acute angle because, it's a little mouth. It's a little mouth, it's a little mouth. It's not going to open very wide. That's what an acute angle is. Now, what's a right angle, you might be asking? Well, yeah, that's our second definition, right angle. And it measures exactly 90 degrees. What? Yeah, so a right angle is depicted usually like this. I'm not perfect, so, this little square usually it implies 90 degrees. And there's only a couple of ways to do it. You can also draw your 90-degree angle like this, or like this, or like this. Basically, if it has this little square here, we know it's a 90-degree angle. You can also put it like this, like a V. So long as you have the little 90, it makes that little square that implies 90 degrees, we have a right angle. Okay? Just a right angle. Pretty straightforward. Next one, we got obtuse. That's Mr. Big Boy angle, right? The special stuff about obtuse angles is that it lies somewhere between, it's bigger than 90, but smaller than 180. What does that look like? Well, let's go over it then. So remember, 90 looks like this, right? Straight up. Obtuse basically says we're gonna copy this part, but we're not gonna land anywhere in this area. Nope, we're gonna be bigger than 90. Maybe we're 100 degrees, right? Or maybe we can be 135 or 150, and you can have it flipped around as well. It could also be like this. Basically, it just opens up wider than 90 degrees. Usually 90 degrees, it's like this. So it has to be bigger. It opens wide. It's a big one. It's an obtuse angle. Okay? And that's the last type of angle we're going to talk about is the straight angle. Straight angles are pretty cool. Why? Because it's just a straight line. Straight angles look like this. It still has the vertex here, but it usually implies that there's 180 degrees. You can also show that vertically. I just think it's 180 degrees. Basically, that's it. That's all we need to know about the 4 different types of angles. Now we're going to go into 2 types of angle pairs. We have supplementary angles, and that's 2 angles whose measurements add up to 180. So if you have angle, so the way you look at it is like, let's say you have 60. Right, well, 60 doesn't really look like that. Let's make it more accurate. You're going to have 60. And then you have this angle right here that's 30. Right? So let's call this angle A, angle B. So measurement of angle A plus measurement of angle B equals 180. Okay, I messed up. It's not 90. These add up to 90. These are not supplementary. These are complementary. I'm sorry about that, guys. Let me correct myself. So supplementary is when they add up to 180. All right, so I messed up. So it could be this angle right here, 150, and we have 30, right? And 150 plus 30 equals 180. So that's how we know they're supplementary. Okay. The other type of angles we have are complementary, and that's our example where we have 60 plus angle 30. 30. 60 plus 30 equals 90. So that's how you know they're complementary. Complementary angles are two angles whose measurements add up to 90 degrees. Okay. And then we have two different types of angle pairs. There's adjacent angles and non-adjacent. All an adjacent angle is an angle that have a common side and a common vertex and don't overlap. So this is what an adjacent angle would look like. We have this, and this. And we can even draw some points, right? We call this A, B, C, and this D. So angle ABC and angle CBD, these two are adjacent. Oops, I'm running out of space. Let me rewrite it. They're adjacent. Why? Because they share the side C and they share the vertex, right? That makes them adjacent, and they're basically touching, all right? The next thing we're going to cover is things with our circles, and it should be pretty straightforward, all right? I'm not going to play any tricks on you guys. We have a chord. A chord is a segment with both endpoints on a circle, right? So we have an endpoint here and an endpoint here, A and B. You see, that's a chord. So that segment AB is a chord, right? A chord can also be from here to here. You can call it C and D, or you just connect them with a line. C and D is a chord. And you just write them like a line segment because, that's what they are. They're line segments, okay? Now we have a special type of chord, and we call that the diameter, all right? The diameter is a chord that passes through the center of the circle. The center of the circle is usually a point, and it has a letter in it, just like all points. And a chord is any line segment that just passes through the center. So this right here is a chord. We're gonna have C and then B, right? So BC is the diameter, right? But also CB is also the diameter. And why is it the diameter? Because it goes from both sides and it passes through the center of the circle, which is A. Okay? Now we have a different type of line segment that goes through circles, but it's not going to be a chord. It's called the radius. And a radius is a segment with one endpoint on the circle. So it could be over here, right? We'll call this J. And then the other endpoint is going to be on the center of the circle. We'll call this K, right? So that's a radius. And basically, there's infinite amount of radii. Like you go in all the directions. It doesn't matter so long as it goes from the center to the edge of the circle. So in this case, we have JK is the radius. But if it gets to the line segment, you can also write KJ is the radius. And that's really all we need to know about our circles. The center is usually just a point in the middle. Now you can do your homework, and your homework is going to be pages 7 through 10 from your Springboard Geometry Book. You're going to do that as homework. All right, guys. Have a great day. Sanchez out.